Welcome to the quick Terranetes walkthrough. My name is Rohith. I'm a product architect here at Appia. So the best place to start is usually at the beginning. So what is Terranetes? So the first line pretty much encapsulates it. In a nutshell, Terranetes is enabling the capability of self-service for cloud resources to application teams. Great, wonderful. But what does that actually translate to? It means that application teams now have the capability to sort of search, configure, and provision cloud resources, whether that's an RDS, an S3 bucket, Elasticsearch, or whatever, but to provision those resources for their workloads in a similar fashion to any other Kubernetes resource. So, I don't know, like a deployment or an ingress or a service or so forth. So you're reutilizing the same DSL, same resource type, same manifest, as it were, to provision those cloud resources. You're no longer having to shuffle those requests anymore back and forth between a platform team. You are effectively able to self-serve. If you were to stop there, that would be fine. In truth, you wouldn't know how it would be that unique. There's probably a number of open source projects out there that deliver a thin veneer of that or a similar outcome. What sort of sets Terranetes apart is the fact that we take on the basis that before you can deliver self-service to application teams, you first need to do it to the platform team. You first need to give the platform team all the bells and whistles, the gears and knobs, the sort of technical controls to make sure that that outcome, self-service for application teams, is done and delivered in a safe environment. So you're taking those same checks and balances that a traditional platform team are responsible for, whether it be costs, whether it be about security, whether it be about enforcing organizational policy, and you're simply automating them in the controller. And that's what Terranetes provides straight out of the box. On top of that, as obviously the name suggests, we are not reinventing the wheel here. We are sort of leveraging a decade's worth of community expertise and investment. We're using Terraform under the hood, so if you've made an investment in that, you don't have to relearn anything new. If you've got any modules, you can use them. If you've got any community modules, you can use those. You're simply reusing Terraform, so you've got all that weight of Terraform behind you. In terms of moving forward, talking about Terranetes, I thought the best way to move forward would be to talk about the two personas that are involved. At a bare minimum, there are always going to be two personas in Terranetes. You're going to have the platform team, who are responsible for the management of the controller, credentials, and policies. And then, of course, you've got the developers, essentially the consumption end, who are responsible for actually provisioning the resources. So if you walk through the user journey of those two personas, you pretty much understand Terranetes. And if you understand how those two sort of rationalize and work with Terranetes, you understand the process in general. So, all right. Excuse me. Alright, so let's start with the persona of the platform team. So imagine I'm someone inside the platform team. My requirement is I want to enable self-service for the resources for the developers. Inevitably, there's going to be a whole bunch of questions I'm going to come across, right? So the first one is going to be almost certainly about credentials management. How are those credentials managed? Where are they stored? Who has access to them? How do I granulate who can access this and who can not access that, and so forth? How many credentials can I have? There's going to be a whole things around those. Next one up is going to be cloud resources, which basically translates into Terraform modules. What can they run? Who can run what effectively? Is it that you can run anything? You can go to the Terraform registry? Is it that you can only come from this approved list? Either way, how do I enforce it? I may have a requirement that you can only use modules from this approved lists. I may not. Next one up is security requirements. Now, I may be responsible for this. I may not be. It may be a DevSecOps team. It may be a completely different team. Either way, how are those security requirements that I need? How are they actually enforced? Lastly, and actually really quite importantly, how is any of this exposed? The worst scenario you could possibly come up with is where you end up with really good functionality but really poor user experience, where you put in a whole bunch of technical controls, but the outcome is you have a whole bunch of developers that are constantly just hitting bricks and hitting friction along the way to get what they want, because they don't really know what's stopping them, what's failing, why it's failing, and so forth. And so you end up just with generating yes, you have functionality, but in reality, all you end up doing is generating a lot of comms between developers and the platform team. And so you haven't really solved your problem. You just probably just have exacerbated it or made it slightly different or made it even worse. So being able to expose those technical controls that you're about to put in and to be able to let developers sort of understand them and rationalize them and hopefully fix it themselves is really very, very important. So let's go to the first question we had, which was credentials management. How do we manage credentials? How do we ensure who has access to what? And how do we granulate those credentials down to individual users? Right, so there is a concept of a provider, which is pretty much a one-to-one mapping of a Terraform provider, in fairness. It's the encapsulation of credentials. It comes in two different forms. It's either secret or it's injected. The difference being secret is basically just referencing a Kubernetes secret, which contains the contains the credentials of some form, whether it's like AWS keys or whether it's I don't know, a service account for GCP. Either way, it's a statically managed secret. It's managed by the platform team. The platform team are responsible for it. They're responsible for rotating it and so forth. It's probably the first entry point, but it's not the best way of using it. The best way of using it is probably to use injected. And injected essentially means that you're now offloading that responsibility onto some of the system. Chances are you're offloading it to a cloud credentials management system. In AWS, that will probably be like IRSA. In GCP, that would be like workload identity. In Azure, it's going to be a similar thing. Either way, what you're saying is I'm offloading the management of that credential to a cloud managed system, and that will then hold that credential, rotate that credential, and it's a hell of a lot more secure than having something that's statically assignable. And of course, you get the whole audit trail and everything. So those are two different forms. That's how credentials in Terranetes is actually stored. The next part is how do you actually filter? How do you actually granularly control who can actually use them? And in Terranetes, and it's a concept which is sort of ubiquitous across all the different resource types, it's a selector, and it's kind of mapped onto like the basics of how Kubernetes works. So it's using matched labels. In this case, I'm simply saying, so for example, let's take the left-hand side. I'm saying that this particular credential can be used by anyone that is inside the namespace special. Great. And on the right-hand side, well, it's pretty much the same thing, but I've got an array rather than a single value, and I can say, well, anyone in apps, and I could add another one like apps 1, apps 2, apps 3, they can use that credential. That's one way of granulating down. Now, if you turn that into real-life working examples, it could be, well, I may have a baseline credential which has limited access, which all the developers can use, all application teams can use, and can scope down to just one or two things. And then I may want a much higher level credential which is used by the platform team because they use that for things like peering, or they use it for things like transit gateway or whatever they're doing inside it. Either way, I want to scope that down just to individual namespaces. That could just be platform system, so for example. Or I may well get even more granular and say, well, I don't want a baseline credential at all. I actually want every tenant inside the cluster to have a different credential. In which case, same thing. You can support both models. You would simply create a new credential and then lock it down to using the selectors to individual namespaces. So out the bat, you have the ability to manage those credentials and who can access and use those credentials. So that's credentials management. Next up is answering the question of what can they run and how do you stop them from running anything. So this may be a thing, it may not be a thing. You can actually implement it in multiple ways. Module security is one of them. Again, we're reusing that same concept of selector. In this case, you can choose namespaces or resources, and as long as those things are labeled in a particular way and it matches, then the actual constraint, in this case module, is applied. Now, the example here is not the best one because it's a .star on GitHub. But in reality, you probably have like, okay, a /appfia or more likely a /myOrganization. And what this is saying is the configurations for the application teams can only be sourced from this array of sources. So you can lock it down to, for example, /myOrganization. And now I can only pull Terraform modules from that particular location. So out the bat, you're simply you're able to lock down. Now, of course, it's basic in the sense that it only works on the source level. So technically speaking, you could source in, I know, module A, but module A imports a whole bunch of modules from all over the place, and it wouldn't protect against that. But the next one, however, does, and that is security policy. So security policy is an integration with a product called Checkoff, which is an open source product. I think it was done off the bat by a bunch of people from Microsoft. It's from a company called Bridge Crew. Checkoff is, like I said, it's an open source project. It's effectively a linter where you can write a series of rules. I mean, out of the box, it comes with about 300 rules across different cloud providers from all types of different things. It then applies those rules against the actual resource types themselves, and as long as you pass, you're great. If you don't pass, you fail, and you can't move forward. The way our integration with this is it applies at the plan level, so it doesn't actually matter whether the attribute that it's checking is in your module or a module you've imported. It's applied holistically, so it ensures no matter what, it can never pass. In terms of what we actually support, you can have checkoff on the left. That just means that I will apply the entire suite or whatever version of checkoff I'm using. One on the left, slightly different. You can use selectors. The same concept can be applied against this one as well. So I can lock down this particular policy to individual namespaces, and of course, if I wanted to, I could override it to say, well, this is my baseline that everyone has to accept. But inevitably, there's always going to be that one or two namespaces that does this, that, and the other, in which case I can apply an override that says, well, I want that plus this, and so you can allow that sort of flexibility. Another way of doing this is to source. It's not actually shown here, but you can actually source it from a Git repository. And this is quite important, and maybe I could do it in a different demo, but it shows how you can use policy as code, where you can use a central repository which is holding your Terraform, is holding your checkoff policies, and you can apply that at both the CI level and apply it, in this case, at the runtime inside the Terranetes controller. What it's allowing you to do is make sure that in the CI level you're failing quickly, so you know that when it comes to the actual runtime, it's not good. You're not going to hit a point where you fail too late, sort of thing. You're failing in the CI. At the same time, if people were to bypass it and not use those checks, it doesn't actually matter because it's still being applied at the runtime inside the actual Terranetes controller. So it doesn't matter which way you came in, it's always enforced. Now, so that's pretty much, at least that's some of the controls. I haven't gone through all of them. There's a few extra ones which I haven't gone through. But in terms of just the summary of those 1 to 2 things that come straight out the bat, you have the ability to control credentials, their source, their rotation, and where they're coming from. And of course, you can also scope those credentials down to, at a very granular level, down to individual namespaces or individual Terraform modules. You have the ability to control the source and the origin of the resources, and you can lock that down again at either namespace level or module level. You can have overrides and add additional things if you wanted to. And of course, if that isn't enough, you can go literally right down using checkoff down to the granular level of an attribute inside that Terraform module. So you can control literally everything if you really wanted to. And of course, like I said, I haven't shown it in this particular example, but you can link that as a policy as code, where you can use a central repository and apply it at both CI and the runtime level. Alright, so much like I did with the platform team, let's go straight into the persona and their sort of requirements around the developer. So I'm a developer. I have a really lost application as a dependency is a database, fine. I know that we're using some sort of self-service thingamajig called Terranetes. I don't know too much about it, but I do know it's based around Terraform, and chances are I have some sort of experience, may not be expert, but I do have probably some sort of exposure to Terraform itself. I have some Kubernetes manifests which represent my application. I've been given a CLI to Terranetes itself, and that's pretty much about it. So pretty much like the platform team before it, there's going to be a whole bunch of questions that developers are going to have. Almost certainly the first question they're going to have is, where on earth do I find these cloud resources? Am I supposed to go to the Terraform registry? Am I supposed to go to GitHub? Or am I supposed to go to the internet? Am I supposed to ask the platform team? Where am I supposed to get this database, my dependency I actually need? So how do we solve that first one? So if we go here, Let's get rid of that for a second and just cap this so I don't have to watch me type. So as I said, we've been given the CLI, which is TN control, which is Terranetes control. It's a standalone binary. It doesn't have to be. You can run it as a kube control, plugin. So let's solve my first problem. I want to find my dependency. So I'm going to do that, search. What resource are you looking for? Okay, give me some suggestions. Good, database. What cloud provider you want to scope it to? It's AWS, but in truth, it doesn't really matter. Even if I didn't know, it would look at the cluster that I'm about to apply it to and use that, AWS. Okay, cool. So at that point, it's gone off and it's aggregated from the resources, from the modules that have been published or have been permitted by the platform team, all the ones that match my term. In this case, the term was database, and you can see we've only hit the one. So I'm going to choose that. Obviously, I could go to this, and I could look at the code if I really wanted to, but I don't really care. Let's go to that. What should the name of the resource be? Let's call it demo. And in this case, cool, I'm going to use the hotfix one because I know I need that. But either way, it's gone off and aggregated all the versions of the particular module that I need. So I'm going to grab this one. Boom, goes off, parses it. What should the value of name be? Or what does name mean? Name of the database. I'll call that demo as well. Environment, don't care. What should the name of the cloud resource secret? Okay, so modules obviously produce, Terraform modules obviously produce outputs. And in the case of something like a database, there's going to be some outputs that you actually need. So, for example, endpoint, username, password, and those kinds of things. What the Terranetes controller does is it takes those outputs from once it's been provisioned and then injects it into a secret. The idea then is you then map that secret to whatever workload you want it to, and that's how the two come together. So I provision it, grab the information, put it into a secret, you then source that secret, everything's happy. What should I call that secret? Demo's fine. Cool. So that's given me what I need to do. I can now take it. I can put it into my manifest. Where do I want it? Let's call it database. YAML, boom, there, don't need that. Cool, and boom, that's it. And that's pretty much search. I mean, and that is, I know, incredibly basic and very simple, and the whole purpose is supposed to be both incredibly basic and incredibly simple. The whole purpose of the developer experience should be that I don't care about the implementation, I don't care about the sources. All I care about is I want to search for that thing. That thing is, in this case, a database, but it could have been a bucket, it could have been Elasticsearch, it could have been anything that I'm allowed to actually run. I simply want to search for the things that I want, give it some sort of local contextual information, or in this case, like the name, and maybe say, for example, the size of the database, or if I was exposing it, the engine that I want to use, maybe it could be Postgres, or maybe it could be MySQL, so forth. I just want to give that local configuration, take it, get what I need, plug it in, and move on with my life. In this case, I've got that information, and of course, I can now apply it. So if then where is that little badger? There we go. Oh, that's a bit quick. There you go. So if I now take that, apply it, and cool. So I've applied my service, my deployment, and my configuration, which is going to build my RDS. So the next question, that solves my first one. I've solved how do I find cloud resources? Well, it's just one command. I just go search, I look for this, that, and the other. It just gives me what I need. I move on. How do I know about the change and what it's about to impact? So, whereas before, the resource would have been managed, like I said, by a traditional ticketing system. Well, if I wanted RDS, can you go and give it to me for DevOps? Now it's not. Now it's being self-served. So now it's technically under my responsibility. And while I may know the impact of the changes I'm making to the code, because I wrote the code, now suddenly I've been given this resource, which wasn't originally under my remit, which now I now manage, and I need to know about that. So I need to know about how do I know when I make a change, what the impact of that change is going to be. Obviously, this is Terraform under the hood, and so that makes it very simple. Let's go back to that demo, and it was to look at I can look at the logs, for example. Sorry, the state. I can see, boom, we are out of sync. I can also see, if I was to look at the logs, everything I need to know. So we see straight away, okay, this is a very big example because obviously it's on the first creation time. But if it was a much if it had already been created and I was just changing on, I don't know, a 1 to a 2 or whatever, it's something small, you would have just seen a slight diff. Either way, what you're giving to the developer is that ability to see the impact, to understand what the severity of that change is going to be, and rationalize it themselves. Now, maybe they don't know what the output this is. Maybe they're not a Terraform expert or have knowledge about this, but either way, they're given that information and they could pass that on to someone else who does know. So you're giving them still the ability to solve their own problems. Okay, so if I wanted to, you can see straight away this was not actually applied. If I go to here, we see it's still out of sync. The reason why it's still out of sync is it tells you right here, which is this. I'm waiting for an annotation. So by default, the behavior of the Terranetes controller is to follow essentially Terraform, its plan, and approve. You don't have to follow that procedure, especially if it's a GitOps approach. You may actually want to just go straight into the apply, in which case you just change spec.auto apply, something like that. But by default, you can see the plan, you can see the output, you can weigh up whether or not you want to go forward with it, and if you're happy with those changes and the impact of that change, you can then approve it. So in this case, I can then approve it. And cool, and you will see straight off that will have kicked off the apply stage. I should have actually said at this point, although you can see these things, so if I was to look at the logs, for example, although you can see these things, you can see the output of the Terraform, of the actual Terraform itself. You do not have any access to the credentials whatsoever. The credentials, whether it be static, whether it be injected, does not matter. They never leave the Terraform system namespace. They never leave the controller namespace. You don't have access to it in any shape or form. All you have is the ability to look at the logs and use that information to debug issues and problems and so forth. And you can see straight off it's going and creating that particular instance. I'm not going to put you through the pain of watching 5-minute creation, so we'll just move on. Alright, so next question. Great. I know where to find stuff. I know what the impact of those changes when I make those changes. But inevitably, someone at some point is going to come to me and say, well, okay, how do you know it's secure? Now, initially, again, this would have been under the remit of the DevOps team. But now you're like, how do I communicate that information downstream? This is a bit like we talked about before, of how do you expose those technical controls to the actual developers, so they know what, not what the state is, but also how to fix their own problems. So let's go on to that one. So if I see here and describe that object, I see everything I need to know. So when that project manager comes to me and says, okay, well, how do you know that's secure? I can tell them straight away. And this is where that integration with, like I said, a checkoff really does pay dividends, because it does provide a lot of information straight out the bat. I can see, well, okay, I have a backup policy. I can see that this instance has all auto upgrade. Great, wonderful. I can see that it has a modern certificate. Awesome. I can see that it's encrypted at rest. I can see that it's not publicly available. So all the things that person was asking me, I can check off. Either way, it's giving that information really neatly to the developer so to see, oh, well, these are the checkboxes that particular modules had to pass before I'm actually able to use it. You can also see here, there's also an integration, for example, with a product called InfraCosts, which also allows the developer to see what the actual costs of that particular resource is going to be. This is only the predicted cost, it's not the actual cost, so the predicted cost doesn't apply the usage as such, but it does give it a really good indication to teams downstream as to how much they're actually costing, and especially if you want to push forward sort of an ethos of cost management, you actually need to, that's not just a single task or a single person, that's actually a team coming together and looking at their costs, and this provides a really easy way for developers to see how much they're consuming and how much they're actually paying. And hopefully they wanted to, because you can look at the outputs of these things, they can also adjust their configurations to get cheaper and spend less money. All right, so how do we know it's secure? Well, we just said we can see everything we need to know about the information right there. And of course, if there's any other checks that are being applied to this, you'd see the entire list. If there are any custom checks, you would see it in the list, and so forth. If there are any custom checks that had custom URLs, again, we'll go to this particular list. What about the reverse? So how do I know when it's not secure? Right? So this stuff isn't here just for the fun of it. It's there to ultimately protect the business. So if I was to look at, for example, this one, this is a configuration. It's using that. We have a checkoff policy. Remember that we have a checkoff policy that enforces, for example, that the retention policy cannot be this. So if I was to apply this, this cat may with me. And I was to watch the output very quickly. So we can see it's in progress. The Terraform plan is now running. It usually takes a few seconds. Terraform's got to run it. It's got to produce the outputs and so forth. And boom, straight away. And we can see, making it smaller, we can see straight away, okay, I passed a good number of things, but straight off I failed on 133, which means that all my instances have to have a backup policy. And the important point of this is this is actually called in from an external repository. A bit like I said before, you can use checkoff in a mode which allows you to, well, you can use Terranetes actually in a mode which could use a central repository as sort of your policy as code. In this case, if I was to look at the repository this was based on, I can show it here. So if I was to do investigating your policy, cool, we can see, well, checkoff is our policy. We can see that this particular cluster is enforcing this repository. And if I was to click on the repository, it's just a demo. We can see that we're only supporting these things. So we're only skipping these particular checks, and you can see straight off that 166, I think it was. 133. Okay, 133 is not one of them. Again, this allows you to tie in that concept of the triangle where you can have CI pointing to these same the same policies, and your runtime using those same policies, and everyone's on the same page. You know that as you're producing modules, or DevOps are producing modules, they're getting applied against those policies, so you know they don't go into a point where the runtime cannot accept it. And at the same time, if they don't follow the procedure and they don't bother to validate against those policies, it doesn't actually matter. It's still going to be applied at runtime. So whether they follow the process or whether they don't, it really doesn't matter. It's always protected. It always checks, make sure the business is protected. And if I wanted to, obviously I could fix it. Give it a 1 and then just apply somewhere. Where is the apply? There you go. Cool. And that will effectively work. That will come in line. But just to verify it. Again, we can see the plan is in progress. We can see the configuration refused because it failed security policy. It wouldn't have mattered if I tried to apply it or approve it. It still wouldn't have gone through. It will fail straight away. Come on, Terraform. And there you go. So we've now come in line, we've passed. If I wanted to, you can see straight off it says that it's stuck here because it needs to be approved. If I approved it, that will go off and create, and we'd spend more out of his money. All right, so let's go back to our questions. So what have we got so far? We know how to find resources, we know what the impact of the resources are going to be, we know if it's secure or not, and we can express that to the developers quite easy. We know what happens when it's not secure. Okay, I gave a fairly simple example of that, but it really doesn't matter. You could have gone to town on it. It would have listed up every possible check you can imagine. Next question is, how do I self-diagnose? Okay, so let's go into debug. Now, this is a fairly important point. Let's go here quickly. Cool. So I have, in this case, I have a configuration, which I'm going to apply. There's nothing special in this particular configuration. There you go. It's created it, and I can watch it. In fairness, you've actually already seen the output of this. But let's have a look. Cool. So I have, you can see right here, I've got an error. I've got the whole purpose of this thing is because you are no longer, like I said, because this is now removed from the remit of the platform team, you need to enable the developer to effectively help themselves. Often the case, especially in multi-tenant environments where you put in functionality, you tend to hide that functionality away because you're scared about exposing secrets exposing secrets across different tenants. The consequence of that is that you end up hiding a lot of the debugging information away from that actual user. And so something like this would have been, it would have failed, you wouldn't know why it failed, and in the end you would have just generated a lot of comms traffic between you and the engineer. The engineer has to then go in, find out why it failed. He has to tell you, they then tell you that you have to change this to that. You then wait for that for a response, and so forth and so forth. This gives it the information up front. We don't expose anything that you can't expose. So we don't expose anything that you shouldn't. Except you never see any credentials, but it gives the developer the ability to help themselves. Now maybe they don't understand what this output means. It's quite possible. But either way, they're given the ability to see it and at least pass it on to someone who does. And again, you're just cutting down that back and forth traffic between developer and the platform team itself. Okay, I think that pretty much covers the demo, searching, impact, how it's secure when it's not secure, and of course how to debug those issues when you need to. I'm going to conclude the demo there. I apologize if it took you long, but I hope it gave better insight into sort of the capabilities of Terranetes and what it can actually provide. Thank you very much.